Okay, we're starting with chapter 1.1 sets. So the first thing, what is the definition? What's the word here for this definition? Any collection of objects. No.
We missed that one. We missed it.
That's okay. All right, so it is a set.
Oh yeah, that would make sense.
A set is any collection of objects. Okay. Very nice.
I know why I didn't answer that one because it was on top, so I was thinking that. Yeah.
You're good. All right, so it's any collection of objects. So we could have like a set of clothes. My set today of clothes is like a brown jacket, a white shirt, blue jeans, and Birkenstock shoes, right? Like that's my set. It doesn't have to be numbers. But a set is always going to be denoted with a capital letter and some braces. And then these are braces. No, on your teeth. They're a little different, yes. Okay, and so then we have some parts of a set. So each object or the objects in a set are called elements or members. Oh, I overstayed my welcome there. It's kind of hard to see. So elements or members. Good. And then, okay, so our next word, it says it's used to state the rule describing the elements in the set. Excellent. Set builder notation. It does. I'm very tan. Set builder notation is there. So that's used to state the rule describing the element. So we've got an example. Okay, set builder notation is C equals, so this is set C, it's the capital letter, like we set up here. So set C is, and so it's saying X, such that X is a letter in the word complement. And we've closed our set. That's set builder notation. Now, the actual set in list notation, if we listed it, would be C equals, we have our braces, C, comma, O, comma, M, P, L, E, N, T. Wait a minute, that's not how I spell complement.
It isn't?
Well, shouldn't it be C-O-M-P-L-E-M, E-N-T? Right?
Why do you gotta do that?
Well, we only list each element once. There was already an M. So we don't list it twice, we just list it once. Okay? There's two E's in complement, but we only list it once. Okay, so order is not important. We could have put it in any order, but each element is listed only once. So set builder notation ultimately looks like this. It's C equals X such that, and then you tell us what it is. So right here was set builder notation, and this is just if you have to build your own set builder notation. This is how you would build your own. And we read the line, when we see this line, we read it as such that. So if I was going up here, X, okay, set C is X such that X is a letter in the word complement. We're going to do one and practice, okay? Good. Example 1, describe set P. It's a picture on page 2. So you're going to need to turn to page 2 in your book because I couldn't copy the picture. With list and set builder notation. All right. So let's do the list first. So P equals. And what do you see in the picture on page 2?
This thing?
Nope, the picture. The actual picture up in the top right corner.
Oh, electronic stuff.
But you have to list it off. Okay, what was I heard? A phone case? Did I hear a phone case? So it's actually, and it's like an armband case, but we can call it a phone case. That's okay because it attaches to your arm like when you're running. So a phone case. What else is there?
There's also another phone case.
Wait.
There's 2 phone cases.
Oh, okay. So one phone case. All right.
There's
A car charger. Headphones. Or earphones. Earbuds. Okay.
Then there's a charger.
Like a sync cable.
Yeah.
Okay.
USB charger.
USB. Okay.
Not the same thing.
They are. So I'll put a sync charger or USB cable, however you put it. So there's 1, 2, 3, 4, 5, 6, 7 things in the picture. A sync or a USB. Put a USB charger. I just heard somebody. A waterproof screen.
Is that the memory card or the phone battery?
It's a battery. It's a phone battery. Okay. And then, what'd you say, Justice, about a waterproof something? Okay. So yeah, it's like a waterproof screen protector. We'll call it.
And then the armband.
Okay, and then there's an armband. Because it's one like you can put your headphone in or your phone in and like run or jog or something. Okay, so we close our set with the braces. So this is the list notation. All right, now we want to put it in set builder notation. So that's going to say, first of all, do you have that written down?
I need this little thingy on it.
Okay, so let's look at the set builder notation. So we're going to start with P equals again. And remember, this up here is how we build our own set. So it's going to say P equals, when we put our braces, X such that X is, what is X?
Electronic stuff.
Okay.
Phone
Oh,
stuff.
phone stuff. Okay. If you read the caption, or if you read the information up here, which we did not do, I don't think. I don't know. We won't worry about it. But we could say phone. What's a better word than stuff?
Accessories.
Accessories. Okay, so we could say phone accessories. X is phone accessories. That was, I would say, that's what I was looking for earlier to show you, but I couldn't find that it was Liam. Okay, so you could put X is phone accessories or X is one of Liam's phone accessories. Because they are Liam's, they're not mine. But it's true. All right, so there's example 1. So do you understand the difference between list notation and set builder notation?
List notation is every single thing.
Yep.
And set builder is like
a broad statement.
Perfect. You got it. Okay, then next up we need a symbol here. So it's like a C with a line, kind of. Means is an element of. A curved E. There you go. Okay, so that means is an element of. So underneath example 1. And so a battery is an element of P, right? We listed it. It was in the list. So that's all we're saying is we can use this. When we see this, it's saying battery is an element of P. What's something else that's an element of P?
the waterproof screen.
Okay, the waterproof screen protector is an element of P. Excellent. The armband is an element of P. Any of those. Perfect. The earbuds. Okay, next up, we have another word that we need. We have the definition. It's a set containing no elements. What is a set containing no elements?
Empty or null set.
Good. Empty / null set is a, sorry that that's slanted, is a set containing no elements. So like I used clothes for an example. Okay, I have twin boys that are 2 at home, and so sometimes their set of clothes is null. Like we just potty trained them a couple weeks ago. So sometimes I turn around when I'm fixing lunch or something and they're running through the kitchen and they're naked because they had to go pee and they took off all their clothes instead of just their underwear, okay? So you can have an empty or a null set, okay, where there's no objects included. The way that we, null. Good try. It is N-U-L-L, null. Now, the way we denote that is we're going to have empty braces with nothing in there. See, that brace symbol wasn't very good. Jeez. Okay. Or it's a 0 with a line through it. Is how you denote a null set.
I'm running really weird E's. I don't know how to do this thing.
That's okay. All right, so here's an example of an empty or null set. So it's D equals, remember we're reading this as such that, X is such that 2 is less than X and X is less than 3, where X is an integer. Well, or 2 is less than X and X is less than 3, where X is an integer. Integers are positive, negative, or 0. So, but there's not an integer, like there's not a number between 2 and 3. So the set is null. So I say we'll do some more examples or some practice of this. Okay, next up, we have the lovely chart. Okay, we're going to fill in the examples down here. All right, so the definitions come first. So an equal set are sets that contain the same elements. Okay, so here we're going to use these for our examples. Set A is 1, 3, 5, 7, and 9. Set B are numbers 3 and 7. And set C, X is such that 0 is less than X and X is less than 10, where X is an odd integer. So let's actually go ahead and list out C. Like this is set builder notation. Let's put C in list notation. So it's any number, right? X, it's saying X is greater than 0, but less than 10. But X is an odd integer. So what's the number that's greater than 0? That's odd. Like what's the first one?
3.
What's the
1.
first one? 1. Okay. 1.
She just said it 3 times.
And then what comes? You're good. You're good. What comes next? 3. 5. 7. 9. And we're done, right? Because it has to be less than 10. Okay, so that's set C. But we just took it from set builder notation, which isn't always very helpful when we're doing this, to list notation. All right, so now, what is an example of equal sets? So we have A, set B, and set C. What two sets are equal?
A and C.
A and C are equal. So we would say set A is equal to set C.
Oh yeah, I do remember these. We did these.
Good, you remember them.
I don't remember them as well because it was a long time.
That's okay. All right, next up we have a subset with this lovely, it's like a really short fat C with a line under it, equal. So every element in B is also in A.
Yeah, so 3 and 7 is in A, but there's also more.
Okay, but there's also more. So we're going to say B is a subset of A. So every element in B is also in A. So we call it a subset. So a subset could be, so we have a set of people, right? Our people is set A. Americans are set B, because Americans are people.
People are not all Americans.
Correct, but not all Americans are people, so we can't say it's a subset the other way. Okay, does that make sense? Or like my subset of clothes today and Wednesday will be different, but I probably will still have my Birkenstocks on. So my shoes, my Birkenstocks, would be a subset of today's clothes and Wednesday's clothes. Does that make sense? Kind of? If we take it, okay, I was like, take it out of math context. All right, so what's another subset you could come up with?
C would be equal
Well,
to
B subsets with C.
B is a subset of C.
Technically, wouldn't it would be considered an equal set, but can't you also say C and A?
You can also say C and A. So you could say A is a subset of C, or C is a subset of A. You can say all those. You guys are awesome with this. Okay, so then we have this fancy one that says a proper subset. Oh man. So B is a subset of A, but B is not equal to A.
No, it'd be A and C if it's equal.
Right, if it's equal, it'd be A and C, but it says B is a subset of A.
B and A?
But it can't be equal.
B to A. But B is not equal A. But B is. But it's subset of A.
So it's really the same one as what we started with. It's B is a subset of A.
Look at me go, guys.
Do we
Okay.
just put a regular C?
Just yeah, it's like a smush C. It's like somebody pressed down on it, or a U-turn sideways. Sometimes they look like C's. I apologize. I don't do the best job of smushing them always.
Okay.
There you go. Again, this textbook is heavy on vocabulary at the very beginning. You can see, I bet. Okay, now, let me get in the right order here. We need some symbols. How do you denote not equal to? A slash. Yes, you want that sideways slash. Good. So not equal to is an equal sign with a slash through it.
Oh, okay. I didn't see where you were.
You're good. I flipped over. You're all right. All right, so how about not an element of? It's going to be that curved E, right? That element sign with a slash through it. You bet. You're good. Not a subset of.
The blanks or a 0 cross out.
Okay, so it's the smash C with a line under it is subset, and then we put the slash through it. And then not a proper subset of.
Just a C.
That smash C.
The smash C with a slash. Good. All right.
Slashing.
I know, right? Like adding a slash to any symbol indicates not. So if we're taking notes, I will use that a lot. I will use the slash symbol a lot for things. Like I'll put the equal sign and the slash and put not equal or whatever. I take a lot of notes. You feel like it's a science class?
No, graph.
Oh, gotcha. All right, so let's look at example 2. So we're given set A, set B, and set C. Okay, these are actually the same sets that we just had. So we have set A is in list notation, B is in list notation, C is in set builder notation.
Do you want us to remake that?
Yeah, let's remake that into list notation. So x such that 0 is less than x and x is less than 10, but they're odd integers. So it's 1, 3, 5, 7, and 9. And then we want to determine if each is true or false. So set 1 is an element of A.
No.
What?
No, because they're not equal.
What?
A has more. So wouldn't it be a proper subset at that point?
All right.
What do you mean? I don't know. It has one in it.
But it's not an element. Or, well, it is an element though.
Okay, so it's
Not the
tricky.
same.
Hey. Okay, it's tricky because it is false. So let me go with that. It is false. You guys have good reasoning here. It is false because it says set 1. Okay, that is not an element of A. However, if it had said 1 is an element of A, that is true. So I'm going to put would be true. And the other thing that would be true is if we said set 1 is a subset. Oh, sorry, is a subset, not an element, but a subset of A. That would be true. See, it's the notation. It's really a pain in the behind sometimes. Like where it gets you tripped up. Does that make sense? You want to talk about it? No? Or just need more practice? Okay. I'm good with that, like, because sometimes that's all it is. We just need to look at more. All right, so let's look at A. A is saying, or B, sorry, letter B is saying A is not a proper subset of C.
So true.
True.
It's just, it said it's not. said it's a proper subset, it would be false.
Okay, so let's go back and look, because a proper subset
Or it'd be true.
said that they are
No,
equal.
I don't
Okay. Okay.
It's true. It's true.
So let's see. A is a subset of C, but it's not a proper subset. It's not a proper subset because A is not equal to C.
They are.
Oh, sorry, because A is equal to C. Yeah, it's not a proper set because A is equal to C. I'm sorry. So a proper subset, they're not actually equal. They can be subsets, but they're not proper subsets if they're equal. Okay, so how about C? B is a subset of C. True. Okay, because we're going to explain it. So all elements in B are in C. And B is not equal to C. It has to have those two things to be a subset or a proper subset.
Are we able to use symbols a lot?
Yes.
Like in our sentences?
Yes.
Okay. So like when I put element, I just put the little symbol.
What symbol do you use for element?
The element symbol, the E.
Oh, yeah. Okay, how about the last one? B is a...
False.
No, not a proper subset. That's subset.
That's just a normal subset. Sorry.
Yep, that's okay. So B is a subset of
Nothing.
nothing. So that is false.
But if it was everything, it would be true.
Right. So neither element of B is found in an empty set. If it was the other way around, it would be okay, actually. So.
Because even though something has something in it, it can also have nothing.
Okay, so let's move to Venn diagrams. Okay, we're going to use these to illustrate relationships between sets. So BTN is between, when you see that in my notes. Okay, so first of all, this Venn diagram is got a box around it. So U is a, who had it?
Union.
Not a union, a universal set. No, it is a union in other things as well, but not in a Venn diagram. So a universal set. It contains all the elements within the context of the problem. So A and B are different, and then union is the other stuff. So if we were talking, again, like say our population was people, okay? So we might have our union might be people at NCHS. And then
The A could be for awesome people.
the A could be like teachers, and then the B could be male.
Why do I understand that more than the actual like?
Because it shows.
Because it's more relatable than the numbers are at this point.
Well, and then it's also like you can see it better that way instead of numbers.
So then who are the people that aren't in the circles? Like if the whole thing is NCHS and this is teachers and these are males.
Females. Female students.
Students.
Everyone else.
Who would be out here? Who's everyone else at NCHS?
Like students.
Students! Yes!
And then female.
Wait, you said B was male students.
I said B was male students. Yeah, so I'm saying,
So it'd be female students?
so if this is the population, the whole thing is the population. You can't see it as I do that. The whole thing is population at NCHS. A is the teacher population. So who's out here, not in a circle? Students. Okay, fantastic. B are the males, but the male what? Teachers, because they're inside of A. So what is outside of B but still in A? Female teachers. Yes. So we just took the universal set and we broke it down to a subset, or to a set, and then another subset. Okay, so we just keep getting it smaller and smaller and smaller. Okay. Now, this one, okay, if we look at this union, okay, or not this union, sorry, this universal set, we notice that G and B, our Venn diagram, don't intersect at all. Okay, but we have in there, we have equivalent sets. Okay, and those are sets with the same number of elements. They have a one-to-one correspondence. So there's 3 girls, Heather, Rhonda, Joy, pardon me, and then there's 3 boys, Jack, Fred, and Ron.
Okay, I also thought that was Jay. So.
That's okay, and they're listed off over here. The set of girls, I have them listed out in set notation. So each element in B can be paired with one and only element in G. Therefore, this is the therefore symbol, the sets are equivalent but not equal. Okay, they're equivalent but not equal. We also call this a disjoint set. Okay, so it's also a disjoint set because, B/C, the sets have nothing in common.